series นะคะ The way to find the answer of the differential equation by using the power series. First, we got to assume y is equal to summation of n equal to 0 to infinity a n x minus x 0 to the power n. Because we are going to assume this as the answer of the differential equation that we are looking for. So we are going to do differential of this term, differential of y, and then we plug it back into the differential equation. Let me give you an example. It might be easier. For example, if I have the differential equation like this, this is the linear differential equation which has the coefficient as a constant. We can use the previous method that I taught to find the answer of this differential equation, right? By finding the characteristic equation. You can try using the first method that we learned before for this problem. And then I'm going to use the power series to find the answer of this one. And then you will see that it would end up with the same answer. Okay? Let's try the first one that we learned. So that means we got to find yc, right? And our characteristic equation is what? M squared minus 1 equal to 0. So you have m is equal to minus 1 and plus 1. So y is equal to c1, right? Now, if we are going to use the power series, the things that we got to assume except that I'm going to find at x0 equal to 0. Okay? Say that y is equal to n equal to 0 to infinity a and x to the power n. Now I'm going to do differential of this term. What will be the first derivative of y? This y. You just shift the x to the power n here. Because a n is just a constant. You just take a look at it as a constant. Take it as a constant. Okay? Get a n. X to the power n, when you do the derivative of it, you would get n x times x to the power n minus 1, right? How do you do derivative? If I said that if I have y to the is equal to x to the power n, the first derivative of y to x is equal to n times x to the power n minus 1. Then just put it there. You would get n because we are going to plug this y into our differential equation. So in that case, in our differential equation, we have the second derivative of y to x. So you got to dip it one more time. What you get if you dip this? n minus 1 x to the power n minus 2. And then we just plug it into our differential equation. If you put n equal to 0 here, what you get? 0. If you put n equal to 1, 0. So I said that. Right? Now, can we do summation of these two terms? We can. Why we can't? Because it won't start at the same point. And the thing is that if we want to do that, you've got to do the shift of the index. You got to shift the power of the x from x to the power n minus 2, make it to become x to the power n. So that means with this term, we got to put n to be equal to n plus 2. Right? If we put n is equal to n plus 2, then our x would have the same power as this term. Okay. So we would get summation n plus 2 equal to 2 till infinity. A n plus 2. This n, you put it as the n plus 2. N plus 2, n plus 2 minus 1, x to the power n plus 2 minus 2. And then this one, n plus 2 equal to 2, then n equal to 0. Now, these two terms, can you do the summation of that? Right? And then, in order to make this whole term equal to 0, it can be two ways. The first one is x to the power n is equal to 0. Or the other way is just that put the 1 in the parentheses equal to 0. But if you assume that x to the power n to be 0, then you would end up with the trivial solution. So the best way is just that making the term in the parentheses equal to 0. So in that case, you would get or an is equal to a. And now what do we do next is just that we just assume if n equal to 0, you would get a2 equal to a0 divided by 2. If n equal to 1, you would get a3 equal to a what? If n equal to 1, you would get a1 divided by 3 times 2. If n equal to 2, you would get a4 equal to 2a2 divided by 4 times 3. But you know that a2 is in the form of a0, so you would get a0 divided by, which is a0 divided by 4 factorial, right? And this one is a1 divided by 3 factorial, and this one is a0 divided by 2 factorial. Now if n is equal to 3, you would get a5 equal to a3 divided by 5 times 4. And you know that a3 is equal to a1 divided by 3 factorial. 5 times 4 times 3 factorial, is that equal to 5 factorial? Right, it is a 5 factorial. N equal to 4, a1, a6 equal to a4 divided by 6 times 5. But a4 is equal to a0 divided by 4 factorial. 4 factorial times 5 times 6 is equal to 6 factorial. So on. Now you know that if a2, a3, a2, a4, a6, a8, it can be written down in the term of a0. And a3, a5, a7, a9, a11, and so on. It's going to be in the term of a1, right? And now you know a. So you just assume that your y is equal to summation of a and x to the power n equal to 0 to infinity, right? This is what we assumed at the first place, and we said that this y is the solution of our differential equation. Distribute this term, you would get a0 plus a1x plus a2x to the power 2 plus a3x to the power 3 plus a4x to the power 4 plus a5x to the power 5 plus a6 times x to the power 6, and so on. The first two terms, just put it right there because it's in the term of a0 and a1. Now our a2 is equal to a0 divided by 2 factorial x to the power 2, right? And our a3 equal to a1 divided by 3 factorial x to the power 3. And next is our a4. a4 is equal to a0 divided by 4 factorial. And a5 is equal to a1 divided by 5 factorial. And a6 is equal to a0 divided by 6 factorial, and so on. Now we are going to put a0 together and a1 together. Okay. For the term of a0, we will get 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial x to the power 4 plus 1 over 6 factorial x to the power 6, and so on. For the a1, we got, take a look at the function. X there, okay. We take a1 out, we got x plus 1 over 3 factorial x to the power 3 plus 1 over 5 factorial x to the power 5, and so on. Right? And then if you take a look at the function that I wrote to you before, the first term is the summation n equal to 0 to infinity x to the power 2n divided by 2n factorial times a0. And the second term is the summation of n equal to 0 to infinity of x to the power of 2n plus 1 divided by 2n plus 1 factorial, which is the a0 of the cos hyperbolic x and a1 sine hyperbolic x. Would it be the same function?